Okay, so good morning and good afternoon. I would like to welcome you to our webinar, which will be focused on very hot topic nowadays. We will talk about the IoT, and we will talk about the BellaDati IoT Data Collector, which is our brand new product. Today is with me Mr. Radek Micka, who will talk about a use case which is focused on data on warehouse monitoring. So, and again, our agenda we will introduce the BellaDati IoT Data Collector, and we will talk about the use case. In this case, it will be about the warehouse monitoring, and the last point will be the question and answer session. So, as I mentioned, very hot topic today. We've got a lot of smartphones, we got a lot of devices around. All these devices are somehow connected to the internet, are somehow collecting the data, and usually you can use them directly, for example, on the smartphones to monitor, the steps or your heartbeats or whatsoever. But of course, the fact itself that we have got many sensors around is not, let's say, not the all, because we need to get the data from various types of sensors. We need to combine them, and we need to do various, let's say, analytics, and as well various mathematical modeling of this. So what are the common issues when we are facing collecting the data from the IoT? So the biggest problem here is that there are different standards, different communication protocols, and of course different formats. Sometimes the sensors are connected over the Wi-Fi. Sometimes they are using the LoRaWANs. In this case, it is long-range wide area networks. The smartphones are usually connected via the GSM, via the 3G or 4G LTE. Then we've got various like Bluetooth devices, which are then connected via phones or via Bluetooth adapters. Then, of course, various communication protocols like TCP/IP. Of course, then higher layers like HTTP, and then the data itself are in various formats like JSON. We can get the data in XML format. Sometimes, of course, we just get the byte streams from the devices, and we need to translate the streams into some meaningful, let's say, records. Another issue could be the real-time data collecting. Of course, in these days, we want to see how the sensors are, let's say, standing at the time. So we don't want to have a historical analysis, we want to have a real-time analysis. And of course, we need to collect the data in real time, not, let's say, once a day. Another point, very important, is reliability. For example, the single point of failure. Devices can be connected to gateways, of course. This gateway may fail, and then the entire system is not working. So this is as well a topic today. Another one is the security. Of course, everybody wants to have it secured. We need to ensure that the data which we collect from these devices are not visible to the others. For example, are encrypted somehow, so you cannot get them in unauthorized way. One of the last points I've got here is the management, and of course this is very important, especially if you are monitoring some, for example, production lines or some as well some buildings. So you can very easily get on the sensors and, for example, restart them. And the last point in my list here, but of course not least, is the integration with advanced analytics and machine learning. So this is something what is missing in the products which are focused just on the data collecting. So, and we think we found a solution. We addressed all these questions, addressed all these points, and we would like to introduce our new product, which is called BellaDati IoT Data Collector. And what is BellaDati IoT Data Collector? The basic functions are to collect the data in real time from multiple IoT elements. Of course, I was talking about various protocol standards and formats. All this is already supported inside particular modules, so you can even get the data from the Bluetooth. You can open, for example, the Telnet server to collect data from the Telnet or using the Telnet protocol. The same for the basic protocols like HTTP. All this is already supported. Then what we are doing with this data, the data are stored in the internal database of particular modules, but of course, the BellaDati, or let's say even another internal modules, can get the data over the REST API from this BellaDati IoT Data Collector. And what is very important, BellaDati IoT Data Collector is providing the auditing and management services, for example, for operational dashboard, which I will show you after the presentation how it can work in the reality. Of course, it provides as well the authentication and secured access, and it can be integrated with BellaDati platform and BellaDati Machine Learning Studio directly. Okay, so you can get the data from the sensors over the BellaDati IoT Data Collector. BellaDati IoT Data Collector can take the data and send it directly to the machine learning, which will process the data, build some models, and update data sets at the end. Very important to say is that particular modules can be extended according to specific sensor or communication standard. So in case the customers are using sensors which are not running on standard protocols, they can get the basic source code of particular receivers. Receivers is a small module which is responsible for getting the data from the sensor, and it can be extended. It can be extended, re-implemented to meet or to, let's say, fit the current standard of that sensor. Okay, and from the top overview, we can imagine that the BellaDati IoT Collector here in the middle consists of three main elements. The most important element, the most important module is the receiver. And since it is a service bus architecture, you can have multiple receivers. Okay, so you can have one receiver, then another one, which will get the data in different format than the first one, and you can have, let's say, 10, 20, 50 receivers inside the infrastructure, and the receivers can then collect the data from the various IoT devices. The most common protocols are, as I mentioned, the TCP/IP, the HTTP protocol. We can as well connect over the Bluetooth, and for example, what's the case of sensors installed on the production lines, we can as well get the data from the analog sensors which are providing just the analog signals. Of course, in this case, we need to use some kind of digital converter, and we already have some use cases with some AD converters which can send the data to the BellaDati IoT Collector. So this is the receiver. So receiver is something which is either accepting the data from the sensors or getting the data on demand from the sensors. Then we have two additional modules. The audit module is responsible for getting the sensor statuses. You can get as well the real-time values to build, for example, some kind of operational dashboard. So you don't need to send the data to the BellaDati. You just need to, for example, use the BellaDati extension to visualize the current data. Okay. How such dashboard can look like? I've got here some example. So this is an example of an. Okay, maybe I need to share it again. So. Okay, so this is an example of such operational dashboard, and what we can see here two receivers which are running in the infrastructure, and both receivers have got two sensors, and both are in the offline mode. But once I switch the sensor to the online, so maybe I can do it right now, so you can see here that I have here Bosch XDK sensor. Once I switch it on, it will automatically connect to the Wi-Fi network and send the data to the collector. So let's wait for a while. Okay, so it seems it's running, and when we open the dashboard again, so we see that the sensors is immediately switched to the online mode, and we can see the current data which are coming from the sensor. So to be able to get this data, we have the audit module. Audit module again is providing the real-time data which are available inside the data collector, inside the BellaDati IoT data collector. Of course, there can be various functions available on the dashboard. Usually we have here the restart function, which you can use to restart the sensor. Of course, you can extend the functionality of this dashboard by extending the extension which is providing this functionality. So for example, you can click on particular indicator inside the dashboard, and you can get some insights on this. So let's continue with the presentation here. So this was the audit module, and the last one is the sender. The sender module is able to send the data to the BellaDati platform, especially to the data sets, and of course to the machine learning studio. And you can use BellaDati SDK to do this in very smooth way, so you don't need to think about the objects, you don't need to think about the way how to communicate with the system. We will just take the BellaDati SDK and use it to send the data to trigger some, I don't know, processes or whatsoever inside the machine learning studio. So this is, let's say, the big image of this BellaDati IoT data collector, and let's take a look on the architecture a bit. So it is a Java application, and it is based on the microservices architecture, and this architecture itself is event-driven. Okay, so it sticks on the events. Once some event is raised, some process is automatically executed and propagated to different modules. Non-blocking, it is highly configurable and scalable. So you can run multiple collectors, you can run multiple receivers, you can run multiple sensors and senders. Of course, this means as well that you can put, for example, a load balancer in front of it. It could be either a hardware load balancer, it can be as well software load balancer, and you can, let's say, load balance the traffic if you got, thousands of sensors. And just the summary, we have three main modules. Audit module, it is providing the auditing services like status of internal modules, receiver senders, and status of sensors, restart of them, current data from them, fresh data from the sensors. The receivers provides the functions to accept the data from the sensors or get the data on demand from the sensor. So it could be bidirectional. Okay, so you can accept the data or you can touch the sensor to get the data. Then the sender modules. The senders are providing the synchronization functions with BellaDati datasets and machine learning. So you can automatically build the complete analytics. You can automatically build the models which are related to the sensors data. So this is regarding the architecture, and maybe last question could be how to get such a collector. It is not publicly available on the websites. It is not publicly available on the My BellaDati portal. So if you want to get the data collector, you can either open a new request in our Jira help desk, or you can contact our support team over the email and describe the case, and we will provide the appropriate distribution to you. Okay, so this was regarding the first part of the webinar. The second part of the webinar will be focused on the use case, and at this stage I would like to hand over to my colleague, to Radek Micka, who will take care of this part. Okay, Radek.
Hi everyone, this is Radek Micka, and today I'm gonna guide you through our use case, which is focused on the warehouses, on the analytics in the warehouses. So the current use case is that we are monitoring the values of several indicators from several sensors in the warehouses. We are monitoring the values which are AHU ability, air temperature, and cold flow. For this, we've got 8 sensors for this case, and we've got here several warehouses. One is bio, second one is food, and third one is pharmacy. And we are monitoring real-time values from these warehouses. All of these real-time values are visualized here on this operational dashboard. And this operational dashboard here, for each sensor, here you see the current value. This is the real-time value. And this operational dashboard, it also compares current values with our limits, with our minimum and maximum. And if current value is outside of the limit, there is sent the alert. And this alert is also visualized on this dashboard. So if you see here this red cross with the value, we see how many minutes we've got are remaining to fix this issue. Because, for example, when we got some food and the temperature in the warehouse gets below or above predefined limit, the food may go wrong, and that's what we don't want to achieve. If we take a look at the detailed values, for example, we can take a look at this sensor, at the current value of this sensor, and after we click on the name of the sensor, we are redirected to the detailed report. This detailed report, it displays current live data, data for last 24 hours, data for last 7 days, and data for last 3 weeks. And in the live report, here you see these are these limits. This is the minimum and the maximum. And we've got here also the critical minimum and critical maximum. And this interval between maximum and critical maximum, it is the time that we've got before we should fix this issue. So that's how we can use this report. If we go back to the dashboard, we can take a look, for example, on another sensor which displays the data which are correct, which are in predefined interval from minimum to the maximum. So, for example, if we take a look at this AHU ability with sensor 6, we see that the current value is between minimum and the maximum. So as a summary, this use case, it monitors real-time values. In case there is some situation, the application automatically sends the alert. These alerts are also automatically displayed on this operational dashboard. And also we've got the access to the live data, and we can also browse through the historical data via clicking on the name of the sensor, and after that we will see the detailed values. We would like to thank you for your attention, and see you next time.